What's up? I'm August, Oakland Senior, 2020. Now, this video I'm going to talk about setting up the plasma table according to the metal you're using. There's all kinds of different metals this thing can do. It can go up to 1 inch, it can go all the way down to 32 gauge, whatever you need to do. There's 3/8, there's 1/8 inch, all kinds of different stuff you need to do. But there are different settings for each different gauge metal that you're working with. I'm sure, hopefully at some point, we're going to have a feeler gauge that you can tell what gauge the metal is at. But start out with, over here on the wall, there's going to be a chart. It explains all the pieces: shield, retaining cap, nozzle, swirl ring, electrode, torch body, all the stuff I cover in the changing out the electrode video. This is what we're going to be looking at mostly. This chart right here. This one is covering your regular ferrous steels. Now, ferrous steels means that it's containing iron. Stuff like aluminum and stainless are a little different. Aluminum doesn't contain iron. Stainless steel has a different process to make it that makes it different. But for iron steels, the ones that we mostly use in here, you're gonna notice right here, there's a gauge, 16 gauge, that's all the chart shows, but there's, you can look up other settings for it if you have a smaller gauge. We have inches. Past 16 gauge, you just measure it in inches. The deer head that I showed you is a 1/8 inch thick steel. We have 1/4 inch, that's pretty common. You can cut stuff out of that. 3/8 is another common one. All the way up to 1 inch, that's as thick as the plasma table cuts. So, metal thickness. Let's say we're working with our 1/8 inch gauge. That's the thickness of the steel. There's millimeters if you need it. PSI. This will always be at 80 plus PSI. Now, the line is going to be run from the lines surrounding the building. You aren't going to have to worry about the PSI. Hopefully not, at least. Next is going to be our pierce height. We're working customary, so from here on, going to stick with the customary. Now, from our 16 gauge to our 3/8, we're going to be working at a 0.16 pierce height. That's the height that the torch is going to pierce the metal. Sorry for the unsteady hand. This is the height that the torch is going to pierce the metal at. Now, our next setting is going to be our cut height. This is how high the torch is actually going to run around and cut the material. That is set at 0.08 for everything. Next will be our pierce delay. This is just talking about how long it takes for the electrode to actually shoot out the plasma after it starts making connection and heating up. So for our 1/8 inch metal, we're going to come over, second column. Our pierce delay is going to be 0.1 seconds. Optimum settings. Next, you're going to have inches per minute. We're going to be set at 220. Now, this plasma table, as I'm sure you will come to find, is very finicky. Mostly in the inches per minute settings. So, when you're setting this, always bump it back about 10%. So, 220, I would run that at 200. That's what we always run it on. That's what it works best at. It cuts slow. I don't know why. I can't explain it. Arc voltage, 128. That's always going to be what this is. That's the optimal voltage that it needs to melt the metal at whatever it's doing. This stuff, production settings, kerf width, edge start, you don't have to worry about any of this. Just this section right here. That's all you got to worry about. So now that we know those numbers, we're going to come over here to our program. We're going to select Job Setup, and it'll bring up this screen. This is going to show you all of the details. Now, there's fancy material sensing, all that stuff that helps you kind of like sense it automatically, but it's not great. I wouldn't use it. So we're going to manually put everything in. Our pierce delay, as we said, is going to be set at 0.1. Our cut height, or our pierce height, is going to be set at 0.16. Our cut height is at 0.08, and our set voltage is at 128. Now, you're probably wondering, where's the inches per minute? It's going to be this, your program feed rate override. I have it set to 300 because of something I was doing, but like I said, the optimal settings is 220. We're going to run it at 200 just because that's what this table in particular works best at. Now, there you go. Your percentage is at 200. That is your inches per minute measurement. You're going to click OK. And you notice it has the same thing right here. You can also adjust that. You can also adjust the inches per minute setting with this. The gauge only goes to 200, but you can type in any value you want right here. And for the most part, that is how you set up any ferrous steel that you want to.